Welcome back to our CompTIA SecurityX series. In this lesson, we are covering Objective 3.5.1. Given a set of requirements, secure, specialized, and legacy systems. We'll explain this in simple language with real-world examples, so you can easily understand and apply these concepts in your work or for your exam. Let's get started. First, let's talk about SCADA and ICS systems. SCADA, which stands for Supervisory Control and Data Acquisition, and ICS, or Industrial Control Systems, are used to manage critical infrastructure like factories, power plants, water treatment facilities, and pipelines. They allow operators to monitor and control machines and processes. The problem is, these systems were originally designed for reliability, not cybersecurity. They often run on older software and can be easily updated. This makes them a prime target for hackers. A famous example is the Stuxnet attack in 2010, where malware targeted industrial equipment in nuclear facilities. To secure SCADA and ICS systems, we use network segmentation, which means separating them from the corporate network and the internet. We also enforce strict access controls, so only authorized personnel can connect, and we use continuous monitoring to detect unusual activity. Next, HVAC and environmental systems. These are the heating, ventilation, and air conditioning systems used in offices, hospitals, and data centers. They are often connected to building networks for easy management. The risk? If compromised, they can become a backdoor into the corporate network. A real example of this happened in the Target data breach of 2013, where attackers got into Target's network through a hacked HVAC vendor. To secure them, we keep HVAC networks separate, use firewalls, enforce secure remote access like VPNs, and apply software updates whenever available. Now let's move on to IoT or Internet of Things devices. IoT devices are things like smart cameras, sensors, printers, TVs, and wearable gadgets that connect to the Internet. The problem? Many of them ship with weak default passwords or outdated software. They can easily be hacked and used in botnets. A well-known case is a Mirai botnet, which use compromised IoT devices to take down major websites. The fix? Change default passwords, keep the firmware updated, and put IoT devices on a separate network away from sensitive systems. Now let's talk about SoC or System-on-Chip devices. A system-on-chip is a tiny chip that contains a full computing system. You can find these in smartphones, routers, smart TVs, and many embedded devices. The risk? They can be vulnerable to firmware exploits. Attackers may install malware at the chip level, which is very hard to detect or remove. To protect SoC devices, we use Secure Boot, which prevents tampered software from loading, and we encrypt sensitive data stored on the chip. Next are embedded systems. An embedded system is a small computer built into a larger device, like ATMs, cars, medical equipment, or industrial machines. The risks include outdated hardware and software that can't be updated and easy physical access by attackers. We secure them by locking access panels, applying firmware updates when possible, and using application whitelisting so only approved programs can run. Finally, wireless technologies and RF, or radio frequency systems. This includes Wi-Fi, Bluetooth, RFID, NFC, and Zigbee, all of which are used in wireless sensors, payment systems, smart devices, and access cards. The risk is eavesdropping on unencrypted communication, rogue access points, or cloning RFID cards. We secure these technologies by using strong encryption like WPA3 for Wi-Fi, disabling and use wireless features, and monitoring for rogue or unauthorized devices. Here's the key takeaway. Specialized and legacy systems are often critical to operations, but they can't always be updated or patched like normal computers. This makes them high-risk targets. The solution is to isolate them from regular networks, enforce strict access controls, monitor their activity, and ensure they are physically secure. That's a wrap on Objective 3.5.1. In the next lesson, we'll dive deeper into additional strategies for securing specialized environments. Stay tuned, and don't forget to review this material. It's highly likely to appear on the exam.